Okay, so this is a 2017 prelim 45N Science Chem Paper 3. Now we're going to go through the section B portion. So let's start. So question 8a, it says dilute sulfuric acid is a common acid found in school lab. Describe three characteristics of all acids and identify the ions that's responsible. So this 4 marks goes to the three characteristics, each one, and then identify the ion. So the three characteristics that we are looking at actually generally is about the reactions that we're looking for. So first one is we must react with reactive metal. Do take note, metal is rejected because copper does not react with the acid itself. Next, acid reacts with bases to form salt and water. Acid reacts with carbonate to form salt, water, and carbon dioxide. So literally, you're just describing the reactions. And last one was the ions that's present, responsible is actually H plus ions. So this is for the 4 marks here. Next, we're going to look at is a student prepare crystal of magnesium sulfate from magnesium carbonate. The procedures followed was in 3 steps. You put a lot of magnesium carbonate in the bottle beaker, dilute acid is added to the beaker until all the magnesium carbonate has reacted. Magnesium sulfate solution was produced. The solution was evaporated to crystallizing point in the evaporating solution. Name the acid used and explain why the acid was not heated in step 2. Okay, so first thing we have is it should be sulfuric acid because I want to form magnesium sulfate. So the sulfate here tells you that I need to use sulfuric acid. Okay, so the back part of the salt name tells you what acid you should use. Okay, and explain why the acid was not heated. So explain why the acid explain why the acid is not heated. Okay, because generally it reacts quite quickly. Okay, so you don't really need to heat it. Or the other one is when you heat it, it actually becomes more dangerous and more reactive. As such, it will actually pose more danger. But generally, you do not need to heat because it's already reacting quickly. Okay, identify the reactant in excess is actually your sulfuric acid. Because this is acid, this is acid plus excess insoluble substance. Okay, this is what you're supposed to add. This substance we are looking at MCB. But if you look at the way how the steps is added, okay, you realize that the magnesium carbonate was not added in excess. Instead, in this case here, the dilute acid was slowly added until all the magnesium carbonate has reacted. All. So when you add, when all the magnesium carbonate has reacted, actually you might have some excess acid over here. So therefore, the excess actually reagent in this case will be the sulfuric acid. So you need to read through the question carefully, and then what will be the impact of it? First thing, solution will be acidic because there's excess acid. The other way is the salt produced will actually be impure. Okay, the salt produced will actually be impure because it will not only be magnesium sulfate, it will be magnesium sulfate plus some sulfuric acid. Okay, so just take note of that. Next one, suggest the effect of heating magnesium sulfate crystals. How would the student know when the crystallization point would be when it had reached step 3? So first thing, okay, when you heat it to the point of crystallization, actually you'll start to see crystals appearing. Okay, or you can tell me the use of a glass rod. Okay, you can talk about the use of a glass rod. So these 2 marks here, obviously, you cannot say crystals appear only. I think really, if you ask me for this part here, we are looking at 1. Okay, is that you'll see crystals appearing together with if you use the glass rod test also. Okay, those of you who do not know what a glass rod test is, you go to your chapter 3 under crystallization. You will talk more about it. The next one is that if you heat, if you heat too much, actually you'll realize that the salt will actually dehydrate and lose water. It'll become anhydrous. Okay, so this is the effect if you heat it too much. This one here is talking about the point of crystallization. Okay, in actual fact, the normal word that you use is a point of saturation. Okay, so the crystallization point is the saturation point. Okay, so just take note of all this little thing for question 8. So question 8 is a test, not in terms of you have memorized the salt preparation method, but more of whether you have understood what the salt preparation method is about. Okay, next. So what we have here is question 9. Briefly describe an experiment using a named compound. So you must name the compound that you're using for the reaction to determine the order of reactivity between the three metals, silver, zinc, and calcium. List the three metals in order of decreasing reactivity. Okay, write a balanced chemical equation for the reaction in one of the metals with a named compound. Now, over here, it says any two. I just want to make some corrections here. Here is not supposed to add cold water, it's to add steam. Okay, because you're adding steam, you won't really see effervescence in the test tube. Okay, you will, in terms, what you observe is the reaction. Okay, reaction. So reaction with calcium, you add with steam, so you get an explosive reaction. Okay, zinc, you get what you're gonna have here is readily react. Readily react. Okay, but for silver, okay, there's no observable change. Okay, so take note here. Okay, when you use steam, in terms of the reaction, okay, the way how you can describe it is slightly different, because for water, you can at least still see effervescence. Okay, you can at least still see bubbling, or you can, but generally, the key idea here is in terms of the how violent the reaction is. Okay, so readily react. Let me write properly. Okay, so explosive reaction, readily react, silver, no observable change. Obviously, because of the three different observations, you can tell the difference in terms of the reactivity. The other one is dilute hydrochloric acid. So dilute hydrochloric acid, all of them will give hydrogen, but generally you will see here the violently, moderately fast does not react. So you can see a graduation in terms of the different degree of reactivity for each of them. Okay, so do take note of this in terms of how to go about describing. We can refer to the metals chapter. Okay, we can refer to the metals chapter. Okay, on the reaction. Okay, next, in terms of the order of reactivity, okay, in terms of order of reactivity, obviously from this you are able to tell the calcium most reactive, zinc followed by silver. Okay, and then any one of this actually will do. Now, because we're not using water, so actually this will not be in the reaction. What you're gonna get is calcium, calcium plus water, plus steam. This one is in terms of steam. Because you react with steam, you're not gonna get hydroxide. You're gonna get the oxide version. Okay. The other one is zinc reacting with steam. You're gonna get zinc oxide plus the hydrogen gas itself. So this is in terms of the reaction that we have here. Okay. So next one under chapter of metals, we talk about the blast furnace. Iron is manufactured in a blast furnace using an iron 3 oxide, coke, and limestone. Write balanced chemical equation for the reduction of iron 3 and the removal of impurities. So reduction of iron 3, actually this is the main reaction here. It is a reduction of iron 3. Do take note, because they're asking for balanced chemical equation, generally you need not, okay, I use the word need not include state symbol. Okay, need not include state symbols. However, I want to highlight that for this step here, you might want to include a state symbol. Okay, these two steps here is for impurity removal. Okay, this step, especially for impurity removal, you might want to include a state symbol, because can you see it's very unique here. It's two solid adding up to give you a liquid. Okay, so this is quite an important step, and the state symbols do prove to be quite important. Okay, so these are the three equations here. Write your chemical equation, balance them properly. Okay, so you have iron 3 oxide react with carbon monoxide to give you molten iron plus carbon dioxide. That's for the reduction of iron 3. Calcium carbonate, you heat it up. Okay, I draw a triangle here to remind everybody that's heating it up. You get calcium oxide and carbon dioxide gas. This thermal decomposition of calcium carbonate. Last one, calcium oxide plus silicon dioxide, which is the sand, the impurity within the blast furnace. Okay, when you mix these two up, you actually get calcium silicate, which we call slag. Right? And this is actually tapped away at the bottom of the blast furnace. Last one, for this question, part C, mild steel is the most common form of steel. Mild steel contains a maximum of 0.3% of carbon. High carbon steel contains 2% of carbon. Okay? it is less malleable and much harder but more brittle than mild steel. Okay, less malleable and much harder but more brittle. Okay, so this less malleable and more brittle actually comes together. Such an explanation why high carbon steel is less malleable and harder but more brittle than mild steel. So this one actually has to do with the alloy versus metal, except that this metal part here you must think in terms of with a little impurity lah. Okay, you know you have done this alloy plus metal comparison, right? So you know that the other elements actually disrupt the arrangement. So the key idea here is we are comparing actually now, instead of alloy plus metal, is alloy versus another alloy. This one has more mix, more other elements. This one will have less other elements. Okay, so now if you look at the answer, so first part you need to say that the iron and carbon atoms, the iron cations or the iron and the carbon differ in sizes in terms of the atoms. Okay, so there's more disruption if there's more carbon. More disruption, regular arrangement in iron if there's more carbon. Hence, there's increased difficulty for the atom layers to slide over each other. Okay, so more carbon atoms, more disruption, more difficulty in sliding over one another. Okay, now the other one is when you add more carbon, the structure is less stressed. Okay, or the other one is when you add more carbon, it distorts the arrangement because it's no longer regular. Therefore, when you hit it, it's easy to disrupt the whole arrangement. Also, it's brittle. Okay, so just take note of this part over here. Okay, this one is, if you ask me, is it purely on textbook? Answer is no lah. Requires you to think a little bit. Okay, and you look at all the past year paper, you realize that there's this kind of question that's coming out more and more, especially at the ending part of section B. So I need you to just be aware of it. Okay, last one, 10A. Okay, question 10. The diagram shows some reactions of ethene. Okay, so ethene become ethane, ethene become a polymer, ethene forms carbon dioxide and water. So each X, Y, Z is actually one of the reaction. So what are the three reactions? X is actually combustion because the product is carbon dioxide and water. So you need to write a balanced chemical reaction here. So combustion actually is a reaction of oxygen. Okay, let me not circle 3, reaction of oxygen. Okay, so once you know reaction oxygen, carbon dioxide and water, you just balance them. So key idea to balance the carbon first, next balance the hydrogen, then last one balance the oxygen. Okay, next one, for ethene, it become ethane. So actually this is addition of hydrogen. So addition of hydrogen or addition or hydrogenation. So this is C2H4 plus H2, addition of hydrogen, becomes C2H6. Last one is actually polymerization, because polymer. So addition, polymerization. Take note the word addition here is important. Okay, because there's actually this thing called substitution polymerization. Okay, that one is not in your syllabus, but there is such a thing. So as such, the word addition here is important. So addition polymerization. So what you're gonna have here is N(C2H4) arrow. Then what you have here. Now this one, actually, if I were to redraw it, it looks like this: CH2. Actually I'll expand the whole thing out. So it looks like this: CH, like this, bracket N. Okay, this is what it's supposed to look like. Okay, so these are the three reactions. 6 marks. Quite good, this 6 marks, if you know. Next one. Air pollutants are released in the atmosphere daily. Name 2 air pollutants, identify the source of each pollutant, and describe the problems that they can cause. So some of the air pollutants, my suggestion is tag accordingly. So there are many different air pollutants. Okay, but I'm just going to go through this few. So if you give me sulfur dioxide, are we looking out for combustion of fossil fuel? Okay, this is the source. And describe the problem that they face. So it forms acid rains which corrodes building. So this is the air pollutant. This is the source. This is the problem, or this is the effect. Okay. Carbon monoxide, okay, this is the air pollutant, this is the source. Okay, this one here is actually the problem. Okay, sometimes people will say difficulty in breathing. We can also accept that difficulty in breathing for people. So people have difficulty in breathing. Okay, so take note of this. Next one, oxides of nitrogen is formed by lightning activity. So this is the source. Acid rain is formed. Okay, when it reacts with water and atmosphere, it will corrode building. So this one is the problem. Last one, methane. Okay, methane is your hydrocarbon. So generally, kettles give off methane due to digestion of food. So this is the source. Contributes to greenhouse gas, which causes global warming. This is the problem. Okay, so there are many different answers. My suggestion is remember this tree. This tree is the easiest and the nicest to remember. Okay, so go and get to know them. And because a lot of questions commonly test on this tree also. So you remember this tree, you're actually overlapping with quite a fair bit of other things that you might need to know and remember also. So that's for section B. Okay, so that's all. If you got any questions, please feel free to ask the teachers, contact them, and to find out more. Okay, that's all. Thank you.